Hi everyone. So in this video, we'll discuss questions from Math Kangaroo year 2023 for grade 5 and 6. As you know, Math Kangaroo is an international competition, so many different countries take part. So the questions from different countries are mostly the same, but there are a few questions that may be different. So I took question set from one country and then looked at question sets from other countries and found out there 10 questions were different. So altogether 34 questions we'll discuss in this video. I wanted to quickly talk about how you can practice these questions. If you go to our website and under the practice tab, you can practice this online. Also, if you go to the same website under resources and then Math Kangaroo, you will find many more resources to practice these questions. So I talk a little bit slow, so feel free to watch this video at a higher speed. Alright, so let's get started then. Holger writes the numbers up to 40 in the table in the same way as shown here. Which of the pieces A to E can he then cut from the table? Alright, so the straightforward way to do this is just write the numbers. Alright, now we can take a look. So we start with 12. So we are taking a piece like this and then going like this. So 12, 20, 21, 29. 12, 20, 21, 29. C is the correct choice. So this approach works fine, but there is a smarter way we can do it. Think about if there are not 40, let's say there are 4,000 numbers, then it will be impractical to write down all the numbers, right? So let me show you another way. Alright, now we can see that, on one there are 8 numbers, and after that, we start again, right? So if you see, if I go this way, the difference is 8. If I go from top to bottom, it's a plus 8, because after 8 we repeat again. After 8 numbers we repeat again. So this is plus 8. And then if I go this way, it's the next number. So it's plus 1. So if this way is plus 1. So out of this, let's see which matches this pattern. So if I go this way, is plus 1. This way has to be 8. So 12 plus 8 has to be 20. So this doesn't work. 12 plus 8 is 20. So this is fine. So this way is plus 1. 21 is fine. But 21 plus 8 is 29. So this doesn't work. Here 12 plus 8 is 20, which is fine. 20 plus 1 is 21, which is fine. 21 plus 8 is 29. So again, you get the same answer. You can check that these two will not work. Matchsticks are arranged to form numbers as shown here. To form number 15, one needs 7 matchsticks. Alright, so this is 1, 2, 3, 4, 5, 6, 7. Alright, 7 matchsticks are needed to form the number 15. To form the number 8, one needs the same amount. Okay, 1, 2, 3, 4, 5, 6, 7. We also need 7 matchsticks to form the number 8. Okay, what is the biggest number that one can build using 7 matchsticks? And we want the number to be the biggest. So when we want the number to be biggest, we want the number of digits to be as much as possible, right? For example, the smallest 3-digit number is bigger than the biggest 2-digit number, right? So we want the number of digits to be as much as possible. And we have 7 matchsticks. So I want to find the number that uses the least number of matchsticks. And I see that 1 uses only 2 matchsticks, right? And I have 7. So I can have, I can use 2 matchsticks, another 2 matchsticks. 2 plus 2 is 4. So I have, the remaining is 3 matchsticks, right? So is there any digit that uses 3 matchsticks? If we just quickly scan through it, you can see that 7 uses 3 matchsticks. Alright, so I can form the number with 2 matchsticks. I can form number 1 with these two matchsticks, I can form number 1. With 3, I can make the digit 7. Alright. And I want the number to be the biggest, so I want the biggest digit to the left. So my number is going to be 711. So this is the biggest number we can make using 7 matchsticks. Then correct choice is D. There is another way we can approach this problem. Actually, we can start from the answers. Since we want the biggest number, let's start from the biggest number, 800. So 8 and 0, 0. But we know that 8 already uses 7 matchsticks, right? So we have no more matchsticks left for 0. So this cannot work. Similarly, we can count the number of matchsticks in 711. And we will see that we are using 7 matchsticks. So I think this will be the correct answer. And since we want the biggest number, we don't have to keep checking this. Which of the shapes cannot be split into 2 triangles using a single straight line? Alright, so we can just try it. I can see that this I can easily do it. Similarly, this I can easily do it. This also I can easily do it. This also I can easily do it. So this is the only one I cannot split into 2 triangles, using a single straight line. So A is the correct choice. There is another way to think about this. So we are using one line to make 2 triangles out of a shape, right? So let's say this is the 2 triangles using one line. So the original shape cannot have more than 4 sides. 1, 2, 3, 4. It cannot have more than 4 sides, right? And you can see this has more than 4 sides, so we cannot make 2 triangles out of this. 9 steps of a staircase arranged in a cylindrical order starting at the bottom and leading all the way to the top can be seen. Alright, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 can be seen. All the steps are equally high. How many steps cannot be seen? Alright, so one thing to notice here is every horizontal level, right, has 1 step. So in this one I do not see 1. Here also I don't see. Here also I don't see. Here also I don't see. Here I don't see. Here also I don't see. This one belongs to this, so there is already a step. Similarly, here I don't see here, 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 and here. This one has already a step here. So I can count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 that I don't see. Anna has 5 discs of different sizes. She wants to use 4 of them to build the tower. She always has to place a smaller one on top of a bigger one. How many ways are there for Anna to build a tower? Alright, the first thing I want to do is number the discs so that it's easier to draw. I will number it according to the size. Smallest is 1, 2, 3, 4, and then 5 is the biggest one. One way we can do this is systematically take 4 of the numbers out of 5 and arrange it and see how many ways we can do it. But there is actually a much easier way. So we are building a tower using 4 of them. That means we are skipping 1, right? So I have 5 numbers, 1, 2, 3, 4, 5. And every time I have to skip 1. Let me skip, say 2. I'll skip 2. So remaining is 1, 3, 4, 5. There is only one way, one and only one way I can arrange them as per the given condition, right? So 5, 4, 3, 1, right? If I skip 2, this is the only way I can arrange them, right? There is no other way because they have to maintain this order. The bigger one has to be on the bottom, right? So, but I can skip each of this one time, right? So I can skip 2, I can skip 1, I can skip 3 or 4 or 5. So there are 5 different options for me to skip. Then there are 5 ways I can do it. 4 ribbons are wrapped around a box. In which order were they wrapped around the box? So the ribbon that is on top is going to cover the ribbon that is on the bottom wherever they overlap. So let's keep that in mind. So if I take a look at this point here, m is on top of n, so I write m on top of n. I write it in this order. And then if I take a look at this point here, p is on top of m, so p is on top of m. Now let's take a look at this point. Q is on top of m, so q is on top of m, so q can be here or here. And then let's take a look at this point here, because we want to find out how key is with respect to p. So here p is on top of q, so p is on top of q, so q must be here, it cannot be here. So the order is n m q p. n m q p. B is the correct choice. Alice has 4 jigsaw pieces, 1, 2, 3, 4. Which two can be fitted together to form a hexagon? So this is the complete hexagon. There are a couple of ways we can do this. The first approach is, draw one of the piece here and then see what the remaining shape looks like, right? So let's do that first. So one appears in, many choices. So let me draw one here. Let me first complete the grid. So this is going to be this 1 point here, 1 point here, and 1 point here. And for this, we will have a point here and here and here and here. So I'll try to draw one on top of this. Let me change the color. Okay, so I have this line, and then this goes one there, here like this, here, and then it goes here like this. So this shape, this is one. So the remaining one then looks like, remaining one is this. Okay, so there are both 3 and 4 look similar to this, but if we look closely, if you look at this and here, 3 is exactly like this. So this piece is extra here, right? Then 1 and 3 will fit to make this hexagon. Then B is the correct choice. There is another way we can do this problem. If you notice carefully, all these shapes are made up of this small triangle. So let's try to split everything in small triangles. Let me first note down the points here. So there will be a point here. So I can split this up in triangles like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this has 14 triangles here. So 2 of the numbers here should make 24. And then I can see that I can have both 1 and 3, 1 and 3, 1 and 3. The 14 plus 10 is 24. I can also have 2 and 3, 2 and 3. They also make 24. So we definitely need a 3 there. And then another thing we can notice is, if you look at this end here, I need a piece that looks like this to complete, right? And that would be this. This will not fit there, so it will be 1 and 3. That is the correct choice. A dark disk with 3 holes is placed on top of a dial of a watch with this diagram. Then the disk is rotated around its center. Which number can be seen at the same time? Alright, so initially we are able to see 1, 5 and 7. So one way you can do is start rotating this dark disk slowly and write down all possible groups. So let's do that. 1, 5, 7, 1, 5, 7, and then if I rotate it by 1, so 1 will go to 2. So basically it will be plus 1, plus 1, plus 1, right? So this will be 2, 5 plus 1 is 6, 7 plus 1 is 8. And again, if I rotate it by 1 more, 2 will become 3, 6 will become 7, 8 will become 9, so on and so forth. And then there will be 12 possible groups, right? Because there are 12 numbers. And then once you write down everything, we can check which one matches. But let me show you another way. See that from 1 to 5 there is jump of 4. So this is a difference of 4 because there is 1 jump, 2 jump, 3 jump, 4 jump, right? So it's 4. 5 to 7 there is a jump of 2. 5 to 6 is 1 jump, 2 jump, right? Then we can check your choices one at a time. 4, 6 and 12. 4, 6 and 12. Here is a 1, 2, 3, 4 is jump of 4 and this is 1, 2. So this matches this. So looks like A is the correct choice. But let me check one more. 1, 5 and 10. 1, 5 and 10. So it's a jump of 1, 2, 3, 4. 1 plus 4 is 5. And then this is more than 2, right? So this definitely is not going to work. Similarly, you can check that the others will not work. A is the correct choice. Jan sticks these 3 pieces of paper on top of a blood circle here. Which picture can he not obtain? All right. So you can see that this is a gray is a semicircle and there are 2 white quarter circles. So let's check the options one at a time. So here I can have the gray semicircle like this, and this is the white quarter circle, so that will work. Here I can have the gray semicircle like this, and then this is the quarter circle, that's fine. Here, if I have the gray semicircle like this, I cannot have gray here again, right? Or if I want to have the gray like this, gray semicircle, I still cannot have the gray here again. So looks like this we cannot make. So C is the correct choice. Let's just double check here. In this case, I can have the gray semicircle like this, and this is the white quarter circle, and this white quarter circle can be like this, right? Here, this can be the gray semicircle. This is white quarter circle, white quarter circle. So everything is possible except C. Franziska writes down 3 consecutive 2-digit numbers. They are in increasing order. Instead of the digits, she uses symbols and writes as follows. What does Franziska's next number look like? All right. When we have 3 consecutive numbers, the tens place will be the same. There is one choice. Let's say, just for the sake of example, 72, 73, and 74. The tens place are the same, and units place increases by 1. Or if I write down the numbers at the boundary, let's say 69, 70, and 71, or 68, 69, and 70. So in this case, there will be 2 numbers whose tens place will be the same, and then it will be 890 or 901, something like that. Here I see that these the tens places are not all the same, so we have something like this. But here the next 2 have the same number, so we have a situation something like this, in fact, right? So these 2 numbers are the same. Okay, so this then we must be a 0, this must be a 1. Okay, now, and this must be a 9, this must be a 9. If this is 1, this is also a square, so this must be 19. If it is 19, the next number is 20, the next number is 21, right? So next number will be 22, 22, and 2 is a heart. So right, so 2 is a heart, so this will be 2 hearts. Then C is the correct choice. A terrace is covered with square tiles of different sizes, so they are all square tiles. The smallest tile has a perimeter of 80 centimeters. That's the perimeter. A snake lays down along the edges of the tiles. See this diagram. All right, so this is the snake. How long is the snake? All right, The smallest tile has a perimeter of 80, so each side must be square. Perimeter is, if the side is a, perimeter is a plus a plus a plus a, that is 4a is equal to 80. So a must be 20. So the smallest side length is 20. So this is going to be 20. This is a square, so this is going to be 20. Now, since this is a square, so this is 20. So 20 plus 20 is 40. So this must be 40. This must be 40 then, because this is a square. This is 40. This is 40 because this is a square. So because this is a square, this is 40. Now, how long is this? So this is going to be this three of the smaller tiles, right? So 20, 20, 20. So there is 60. So this is 60. Now, this is a square, so this has to be 60, right? So that is until here. Then this is 20. This is 20 and 20. So now if we add it up, so 20, 20, 40, 40, 80, 120, 160, this 200, 240, 300, 360, 380, 400, 420. This is the correct choice. The picture of a digital watch can be seen in a mirror. So this is the reflection in the mirror. Which picture of the watch can be seen in the mirror 30 minutes later? All right, so what we are seeing is the reflection. So let's say the watch is somewhere here, and what we are seeing is the reflection, and this is the mirror. All right, so what we will see here 30 minutes later. So can I add 30 minutes to this? No, right? So this is not the actual time. Actual time is somewhere here. So let's try to draw the reflection. And questions like this where you have to draw the reflection, it comes up many times in Math Kangaroo and other math competitive exams. So if you know how to draw the reflections, great. If not, I have just made a video detailing how we draw reflections. So please check it out. I'll put a card in this corner or this corner. So please feel free to check that out. Okay, so let's try to draw the reflection here. So this line will be somewhat like this. Here it will be like this. This will be this. This will be this. This will be this. So 5 will look like a 2. So this is also a handy trick to remember. 5 looks like a 2 and 2 looks like a 5 in the reflection. So that when you see this number, you can draw the reflection very quickly. 1 is just a straight line parallel to the mirror, so 1 will stay like that. And then 2 again will look like a 5. You can verify. And then 1 will stay like that. So 30 minutes later, so this is the current time. I will add 30 minutes to it. So this is 1. 5 plus 3 is 8. So that is 80 minutes. So I will carry over 60 minutes. So the remaining will be 20 minutes here. And then, so I'm carrying over 60 minutes, which is 1 hour. So this 1 plus 1 is going to be 2 and then 2. So this is the time after 30 minutes. But I'm not looking for this time. I'm looking for the reflection of it, right? So what I will see here in 30 minutes. So let me reflect it back. So again, this 2 will look like a 5. This 2 will look like a 5. This 2 will look like a 5. Then 1 will remain the same, right? So 1555, 15D is the correct choice. Okay, now I have some questions for you. Why did I take the line of reflection to be here? Why not here? Or why not here? Or why not here? Let me call this A, this B, this C, this D. So let me know in the comment what happens if I take the line of reflection to be B, C, or D. I will give you a hint. I wrote down the actual time 21:51. As you can see, the actual time is 21:51. So I wrote that down on a piece of paper, and here I'm holding the paper on the left side of the mirror. So this is the mirror. Here I'm holding the paper on the right side of the mirror. Here I'm holding the paper below. and you can see the actual and the reflection. So think about it and let me know in the comments. Maria, Peter, Richard, and Tina play football in the classroom. While doing so, a window pane broke. When the headmistress wanted to find out who broke the window pane, she got the following answers. Maria, it was Peter. Alright, so there is some blame game going on. So let me write down the names. M for Maria, P for Peter, R for Richard, and T for Tina. Maria, Peter, Richard, Tina. Alright, Maria says it was Peter. So Maria is blaming it on Peter. Peter says it was Richard. Peter is blaming it on Richard. Richard, it wasn't me. Richard is saying it wasn't me. Tina is saying it wasn't me. Alright, so Tina is also saying it wasn't me. Later, it became clear that only one child spoke the truth. Alright, so who broke the window pane? So let's first assume it was Maria. If it is Maria, Maria is saying it was Peter. So Maria is not telling the truth, right? Peter is saying it is Richard. So Peter is also not telling the truth because it was Maria who broke. That's what we are assuming. Richard is saying it wasn't me, so Richard is telling the truth. Tina is saying it wasn't me, so Tina is also telling the truth. Okay, Maria. So let's assume it was Peter. So Maria is saying it is Peter, so Maria is telling the truth. Peter is saying it is Richard. Peter is not telling the truth. Richard is saying it wasn't me, which is true because it was Peter. Tina is saying it was me. So Tina is also telling the truth. Okay, now let's assume it was Richard, right? So Maria is saying it was Peter. So Maria is not telling the truth. Peter is saying it was Richard. So Peter is telling the truth. Richard is saying it wasn't me, right? So Richard is not telling the truth because we are assuming it is Richard. And Tina is saying it wasn't me. So Tina is telling the truth. And then remaining is Tina, right? So in case of Tina, Maria is saying it was Peter. So Maria is not telling the truth. Peter is saying it was Richard. So Peter is also not telling the truth because it was Tina. Richard is saying it wasn't me. Richard is telling the truth. Tina says it wasn't me. So Tina is also not telling the truth because it was Tina, right? So in every case, in this case, two people are telling the truth. In this case, three people are telling the truth. In this case, two people are telling the truth. Here, only Tina is telling the truth. So we can B is the correct choice, and E is definitely not the correct choice because we can definitely determine it. The sum of the numbers in white and in the gray field should be equally big. Which two numbers have to be swapped so that the sums are equally big? Alright, so let me write down the numbers in gray first. G for gray. 1746, 1746, and 2. So this is going to be 1 plus 7 is 8, plus 4 is 12, plus 6 is 18, plus 2 is 20. And W for white, the numbers in white are 3, 5, 8, 3, 5, 8, 11, and 13. So this is going to be 3 plus 5 is 8, plus 8 is 16, plus 11 is 27, 30, 40. So this is going to be 40. And I want these sums to be equally big. So let me check one choice at a time. Let's start with this one, 1 and 11. So I'm swapping 1 and 11. Then in this case, I'm taking away 11, adding 1. So 40 minus 11 plus 1. So this is going to be minus 10. So 40 minus 10 is 30. All right. Here, I'm taking away 1, adding 11. So 20 minus 1 plus 11. So this is same as like I'm adding minus 1 plus 11 is plus 10. So 20 plus 10 is 30. And these sums are the same. So A is the correct choice. If this did not work, you check the other one. But in Math Kangaroo, there is only one correct choice. So it must be A. The big rectangle is made of 5 smaller rectangles. See this diagram. Lukas wants to color the small rectangles in red, blue, and yellow. Two rectangles next to each other should be colored in different colors. All right. So two rectangles that touch each other, they must have different colors. How many ways are there for Lukas to do that? All right. So let's start with red. Now notice that this is touching the other two, so these three have to be different. In fact, any three that are touching each other, right? Let's take these three, they have to be different color. So if this is red, let's say this is blue and this is yellow. Once we have this figured out, this is already determined. This cannot be yellow or blue, so this has to be red, and this cannot be blue or red, so this has to be yellow. So once we fix these three, these two we don't have many choices. There's only one choice, right? But these three, I can choose this to be red, blue, or yellow. So there are three ways I can choose this. But once I choose one, the other one, I'm left with two other colors. So I have two ways to choose that. Once I fill that, I have only one color left. So this is total of 6 ways. And once I choose this, the others are already determined, right? I don't have choice there. So total I have 6 ways. D is the correct choice. 4 posts are placed along a 120-meter long running track. How many more posts have to be placed so that the running track is split into equally long sections that way? You can probably realize that this is a GCF problem, greatest common factor. So let me find the GCF of 24, 30 and 66. First, they are divisible by 2. So this is going to be 12. This is going to be 15. This is going to be 33. And then they are divisible by 3. So this is going to be 4, 5 and 11. Alright, so GCF is multiplication of these numbers. So 2 times 3 is 6. Alright, so GCF is 6. That means I will be able to divide in segments of 6 meter long. So let's do that. If I divide this in a segment of 6 meters long, how many segments will be there? Four segments, right? So this is 6, 12, 18 and 24. So there are 4 segments. But how many more posts I need? I need one less because they are already at the boundary, right? So 4 minus 1 is 4 minus 1 is 3 more posts I need here, right? So 1, 2, 3. All right. Similarly, if I divide this into 6 meter long segments, I will have 5 segments, but I will need one less. So 5 minus 1 is equal to 4 more posts I need here. Similarly, here, if I divide it into 6 meter long segments, there will be 11 segments, but I will need one less because they are already at the boundary. So I will need here 10 posts. So the 10 plus 4 is 14 plus 3 is 17. C is the correct choice. Notice one thing though. So this is the minimum number of posts I need, but it doesn't ask minimum, right? So if 17 was not one of the choice, but let's say a multiple of that, let's say 34 was one of the choice, then you would pick that. In a game, one is allowed to take some or all building blocks from the top of a stack of buildings, turn them upside down and place them back in the same position within one move. See diagram. Here I'm taking some of the blocks and I'm turning them and putting them down. Alright. Goran starts with the stack of buildings, this stack. In the end, the building blocks should be ordered according to the size like this. Alright. So the biggest one is on the bottom and the smaller one on the top, and so on and so forth. What is the minimum number of moves Goran needs to make? In problems like this, sometimes it is easier to represent the size with numbers so that you don't have to keep drawing the sizes all the time. So I'll tell the smallest one as 1, the next is 2, 3 and 4. This is according to the size. So I'm starting with 1, 4, 2, 3, and I want to end up with 1, 2, 3, 4. All right. Notice that when I remove some blocks from the top, I have to all together I have to flip it upside down, right? So I want 4 at the bottom, but the way I can do is first I have to take 4 to the top. So let's first flip this 2. So if I flip this, it will be 4 and 1, and this is going to be the same 2, 3. Now I want 4 at the bottom, so let me flip the whole thing. So 4 will be here, and then 1, then 2, and then 3. Okay, 4 is at the bottom. The remaining, but I want the order 4, 3, 2, 1, and I can see that then I can just flip this one, right? So then this is going to be 4 stays as it is. So 1 goes to the top, 2, and 3. So I've ended up 1, 2, 3, 4. So how many flips I need? So here I needed 1 flip, 2 flip, 3 flip. So I need a minimum of 3 flip. B is the correct choice. Okay, so B is the correct choice. Robot and Sonja play a game with the following rules. Taking it in turn, they can take 1, 2, 3, 4, or 5 cards from the pile on each move. Whoever takes the last card has lost. At the moment, there are 10 cards on the pile and it is Robot's turn. How many cards should he leave for Sonja so that he can be certain to win? This is a very nice problem, bit difficult to explain, but let me try my best. Let me write down the number of possible cards on the stack. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Currently, we know that there are 10 cards, but let's examine each of these numbers. So, let's say I'm a robot. So, I will try to find out what is the winning number of cards on the pile. So, when it is my turn, how many cards should be there on the stack so that I'm certain to win? Okay, let me check each numbers. So, if there is only one card remaining on the stack, when it is my turn, I have to take that card and I lose. So this is not a winning number for me, this is a losing number for me. When there are only 2 cards on the pile, I can choose to take one card, right? I can choose to take one card so that the last card is for the other person. So I'm certain to win, they are certain to lose. Similarly, I can take 2 cards, right? And the remaining one card the other person will be forced to take. So I'm certain to win, they are certain to lose. Similarly, I can take 3 here, and I'm certain to win. I can take 4 card. I'm certain to win. I can take 5 card, and I'm certain to win. And I can take at most 5 card, no more than that, right? When there are 7 cards, I can take as little as 1 card. There will be 6 cards remaining on the pile, or I can take as many as 5 cards. So there will be 2 cards remaining on the pile. So anywhere from 2 to 6 cards will be remaining on the pile, right? But I know that 2 to 6 are the winning numbers. So this is the sweet spot, right? So if there are 7 cards on the pile, no matter how many cards I take, there will be anywhere from 2 to 6 cards remaining on the pile for the other person, and they are certain to win. So I'm certain to lose, right? So this is not a winning number for me. Actually, we already have the answer, but let's also check the other numbers. Now I know that 7 is a losing number, so I can choose to take one card here and leave 7 so that the other person is certain to lose, I am certain to win. If there are 9 cards on the pile, I can choose to take 2 cards so that there are 7 cards on the pile so that the other person loses, I win. If there are 10, I can choose to take 3 cards so that I leave 7 cards for the other person so that they are certain to lose, I'm certain to win. So robot wants to should leave 7 cards on the pile so that he is certain to win, the other person is certain to lose, right? Then C is the correct choice. Actually, there is another way I can explain this. So let me erase it first. All right, now there are 10 cards and it is robot's turn, and robot can take anywhere from 1 to 5 cards, leaving 9 to 5 cards for Sonja. All right, now the goal is to leave the final 1 card for your opponent so that they're forced to take that and they lose. So what Sonja can do is she can take 4 cards in this case and leave 1, forcing robot to take the last card and lose. So we don't want to leave 5 for Sonja. In this case, she can take 5. She's allowed to take 5 and leaving 1 for robot, forcing him to lose. So again, robot doesn't want to leave 6 cards for Sonja. In this case, Sonja would like to take 6, leaving 1, but we are not allowed to take more than 5. So the minimum we can take is 1. So -1 will leave 6 for robot. Or if Sonja takes maximum of 5 cards, that will leave 2 for robot. Now what robot can do is, again, the goal is to leave the final card for your opponent, right? So in this case, robot can take 1 card, leaving 1 for Sonja, right? Or in this case, robot can take 5, leaving the final one for Sonja, forcing her to lose. So this is the number of cards we want to leave for Sonja. But let's check 8. In this case, Sonja knows that if she takes 1 card, 7 will be remaining for robot, and 7 is a losing number. So in this case, robot will lose. So definitely we don't want to leave this for Sonja. Similarly here, we know that if Sonja takes 2, 7 will be remaining for robot, and 7 is a losing number. So robot doesn't want to leave 9 for Sonja, right? Again, C is the final choice. A rabbit, beaver, and a kangaroo are having a competition. All three begin at the same time from start. This is start, and hop in the same direction. The beaver always moves 1 position forward with each jump, or beaver 1 position. The rabbit always moves 2 positions with each jump, and the kangaroo always moves 3. Whoever takes the least amount of jumps to land exactly in the position called Ziel. Alright, so this is the position, is the winner. Who wins the competition? Alright, so beaver moves 1 position with each jump, rabbit moves 2 positions with each jump, and kangaroo moves 3 positions with each jump. So let's say this is the first position, second position, third position, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So this is going to be 22. All right. So beaver moves 1 position in each jump. So to get to 11, it will need 11 jumps, right? Let's talk about rabbit. So rabbit is 2. The next time it will be on 4, 6, 8, 10, 12. So it's going to miss 11, right? So it's going to go all the way to 22 and continue jumping, right? So first time around this is 11, this is 22, so it's increasing by 11. So next time around, 22 plus 11 is going to be 33. Next time around this position will be 33. 33 plus 11 is 44. 44 plus 11 is 55, so on and so forth. So as you can see, the rabbit is going to land only on even numbers, right? 2, 4, 6, 8, like that. And this position is always going to be odd, right? So it is never going to land here. So rabbit, never. All right. Kangaroo jumps 3 at a time. All right. So the first time around, it is going to miss this position because 11 is not divisible by 3. The next time around, it is 33. So 33 by 3 is 11. So it will require 11 jump to reach here in the second time around. But it will need 11 jumps, right? So both beaver and kangaroo are needing 11 jumps. Rabbit is never reaching there. So beaver and kangaroo, they are going to win the race. Tina draws shapes into each field of the pyramid here. Each field in the second and third row contains exactly the shapes of the 2 fields below. So this is the second, this is the third, of course this is the first row. So each one contains the 2 below. So this will be sum of this and this. Okay. Which shapes does she draw into the empty field of the bottom row? So what is this? So let me call it X. So this will be this plus this. So it will be X and a circle and a square. So this will be, a circle and X. So this is a sum of this and this. Okay. Now this then is going to be sum of this and this. So I have 2X. And then I have 2 circles, plus circle, and I have a square, right? So this is going to be same as this. So I have 2 circles and a square. So I can take out 2 circles and a square. So this is gone. So 2x is basically this. So then x is half of this. Half of this will be just 1 circle and a triangle. So then one circle and a triangle. D is the correct choice. A tower is made up of bricks that are level with numbers from 1 to 50 from bottom to top. So 1 to 50 from bottom to top. Bob uses these bricks to build a new tower. Each time he takes two topmost bricks of the old tower and places them down on the top of the new tower without changing their order. See the diagram. Alright, so we are taking the top two and starting to put them on the new tower without changing the order. It is 50, 49, 50 on the top, 49 on the bottom. All right, then the next two, let me write down the next two here. So this will be 48, 47. So we take these two here and 48, 47, they go like that. Okay. Which two bricks lie on top of each other when he is finished with the rearrangement? One way to do this is actually write down all the number and then check each answer one at a time. But let us try to find some pattern, right? So the next two, let me write down the next two here. So this is going to be 45 and this is going to be 46, right? And so on and so forth. It will continue like that. Now, if you notice, every time there is an even brick, the top number is going to be 3 less and the bottom number is going to be 1 less. 48 minus 1 is 47, 48 minus 3 is 45. Or if you take a odd brick as a reference, the top number is going to be plus 1 and the bottom number is going to be plus 3. And this works for any of those bricks, right? And we'll try to see which answers matches this pattern. So we can check either this pattern or this pattern, any one is fine. So if 29, this is an odd number, then it has to be a plus 1 or plus 3. So but this is less, right? It's less than that, so this is not going to work. If it is 34, let me just check this pattern because this is even number. It has to be 3 less or 1 less, but this number is more. That's not going to work. If I check this one, it's an odd number, so it is to be plus 1 or plus 3, but this number is less, so this is not going to work. Here, this is odd, plus 1 or plus 3. So plus 1 will lead to 32 or plus 3 will lead to 34, but not 33, right? So this is not going to work. So 27 is the odd number. Plus 1 is going to lead to 28 or plus 3 is going to lead to 30, and 30 we have it, right? So E is the correct choice. Martin has 3 cards that are labeled on both sides with a number. Martin places the 3 cards on the table without paying attention to back or front. He adds the three numbers that he can see. How many different sums can Martin get that way? Alright, so we have 3 cards, 1, 2, 3 on the table. Either it can be back or front. So there are 2 choices for this, 2 choices for this, 2 choices for this. So there are going to be total 8 sums, but some of them may be duplicates. So let's write it out. The first card can be a 1 or a 4, and for 1, so that is this one. The second card can be either a 2 or a 5. Here it can also be a 2 or a 5, and for each of those, it can be 3 or 6. So it can be 3 or 6. It can be 3 or 6. This can be 3 or 6. This can be 3 or 6. If I add it here, 1 plus 2 is 3 plus 3 is 6. 1 plus 2 is 3 plus 6 is 9. 1 plus 5 is 6 plus 3 is 9. 1 plus 5 is 6 plus 6 is 12. 4 plus 2 is 6 plus 3 is 9. 4 plus 2 is 6 plus 6 is 12. 4 plus 5 is 9 plus 3 is 12. 4 plus 5 is 9. Plus 6 is 15. So there are some duplicates, as you can see. So there are 2 9s here, so I can get rid of 1. But there is one more 9 here. then I see a 12, there is a 12, there is a 12. So I have one, two, three, four different sums, and 4 is not one of the choice, so a different number is the correct answer. Anna has two machines R and S. If she places a square piece of paper in machine R, it is rotated 90 degree in a clockwise direction. All right. If I put a piece of paper and through the machine R, it gets rotated clockwise 90 degree. You can see this dot ends up being here, 90 degree here, right? Here, this dot ends up being here. If she places the piece of paper in the machine S, it gets printed on it. All right. So I'm starting with this. Wait, let it go through machine S. It gets printed a shape. She wants to produce this picture. She wants to produce this picture. In which order does Anna use the two machines so that this picture is made? All right. So we start with this. We end up here. This is same as this. So in which order we need to put these machines? Okay. First thing is, this shape is a little complicated. So instead of this, I'll just draw an arrow, right, to represent that shape. Makes it pretty easy. So here I want to end up with a shape like this. Arrow is down, and then, sorry, arrow is down and the dot is here. All right. So first of all, notice that this dot ends up here, right? So we need 1, 2, 3 rotations. So I need 3 hours. So this has only 2 hours, so this is not going to work. This has only 2 hours. This is also not going to work. So we don't even need to check those. So we'll check the other 3. So let me start with S, R, R, R. So I'm checking choice C. So first time I put through the machine S, it gets printed. So the dot remains at the same place and it gets printed like that. Rotation will rotate it. So this dot will end up here and this will rotate one time like this. Again rotation. So this dot will end up here and this will get rotated like this. Here one more rotation. This dot will end up here and this will get rotated, will end up like this, but this doesn't match this. So this combination is not going to work. A is not going to work. So let me erase this. Now let's check B. R, S, R, R. So first I'm rotating it. So this will end up here. This is going to end up here. All right. S, then I'm printing on it. So this dot is here. Then I'm printing on it. When I print, it gets printed like that. Okay. And then I rotate it. So this dot will end up here. This arrow will rotate 90 degree. Okay. And here, this dot will end up here. That will be here. And this will get rotated 90 degree. End up here. And that matches this. Then B is the correct choice. You can check yourself that D is not going to work. Monika wants to find a path through the labyrinth from start to Ziel. Start to Ziel. She has to stick to the following rules. She is only allowed to move horizontally and vertically. She cannot move diagonally. She has to enter every white circle exactly once, but is not allowed to enter a black circle. In which direction does Monika have to move forward when she reaches the circle marked with X? Alright, so when she reaches X, we can just try it out actually. So let me start here. Here I have only one choice. I cannot go this way. So I go like this. Okay, I'm kind of getting stuck there. So let me go like this. Okay, again I'm stuck. Okay. So I'll get stuck there. And then I want to grab these two. So how about I go like this and here, here. All right, I made it. So here I'm going down, right? Similarly, you can actually check, and then you will see that this is the only way. So I've already tried many different times. So I don't know any better technique for this. So if you have a better technique, let me know in the comment. Thank you. Rosa folds the net shown below to form a cube. So this is the net. Which of the following 5 cubes can she get from this net? Alright, so this is a 3D problem. Oftentimes 3D is a bit difficult for me to visualize, so I try to find relationship between 2D shapes. For example, here if I take the blue kangaroo, the head is connected to a green. The nose, when I fold it, right, the nose has to be connected to this green, and the feet will be connected to this green. So let's first check that. Here the nose is not connected to a green, it is connected to another yellow kangaroo, so this is not going to work. Here it may be, the feet also may be, that's fine. So here the nose is connected to a green, but the feet is not connected to green, right? So this is not going to work. Here I'm not even able to see the blue kangaroo, so I don't know. Here the nose is connected to a green, but the feet is, sorry, I should be looking at the blue kangaroo. The nose is connected to a green, but head should be connected to a green, right? So this is also not going to work. So I have to look at choice B and D. Now what I will do is, let me try to represent the kangaroo in a very simple shape. So this kangaroo has an arrow like this, and the tail is here. This kangaroo is also arrow like this, and the tail is here. So when I fold it, the head and head should be aligned, right? And but if I look at this, when it is folded, the head is aligned with the bottom, right? So this is also not going to work. So the only dominating choice is B. So this must be the correct answer. But let's just double check. Here if you see, the head of yellow kangaroo is connected to the tail of the blue. So when you fold it, the head will connect to the tail, and this tail is going to connect to the head, right? So head to the tail and tail to the head. So this indeed looks like the correct choice. Which two tiles should be used to complete the puzzle? For a problem like this, when I have to fit the puzzle piece aside, the first thing I try to do is actually quickly count how many smaller units are missing. So let me do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 pieces that are missing. All right, so let me count here. 1, 2, 3, 4, 5, 6, 7. So this has 7 pieces. 1, 2, 3, 4, 5, 6, 7. This has 7 pieces. 1, 2, 3, 4, 5, 6. This is 6 pieces. 1, 2, 3, 4, 5, 6. This is 6 pieces. All right, so 1 and 2. 1 and 2. 7 plus 7 is 14. So this is definitely not going to work. 1 and 4. 1 and 4, 7 plus 6 is 13, so it may work. 2 and 3, 2 and 3, 7 plus 6 is 13, it may work. 2 and 4, so 2 and 4, 7 plus 6 is 13, it may work. 3 and 4, 3 and 4, 6 plus 6 is 12, so this is also definitely not going to work. So what is remaining is to check these 3 choices. Now I'm assuming that the pieces are not rotated. So if you look here, right, so this this kind of matches with this and this here, and it also has this two here. So seems like this is one of the pieces. Now so 4 should be in one of the pieces, so this is not going to work. So 2 4 or 1 4, 4 with 2 or 4 with 1. All right, so if I now look at some of the patterns here. I need these two pieces, they kind of match there, and that also has this one here, right? So it seems like 4 and 2, they also add up to 7 plus 6 is 13. So these are the missing pieces. D is the correct choice. The gear marked A is turned clockwise here as shown. Which two boxes will move upwards? Alright, so this gear is moving like this. They're connected together, so this will move like this. When this is going to move like this will move like this. When this is going to move like this is going to move up. So 2 is going to move up here. Now when this is going to move like this is going to move this way, right? So they're connected together, so this is going to move this way, this is going to move this way, so this is going to move this way, so this is going to move this way. So when this is moving up, 3 is going to move up. So then B is the correct choice. Martha chose one of the 5 structures below. See the choices. These are the choices. And combined it with the structure given. Alright, this is the structure that is given. The table shows the number of cubes in each column in the combined structure when seen from above. Alright, so when we see from above, this table gives the number of cubes. Which of the 5 structures did Martha choose? Alright, let me also represent this in terms of this table. So this is going to be, so I have, if I look from the top, so I have 3 here, here I have 2, here I have nothing, 0. In the next row I have nothing, 0, 0. Here I have 2. Here there is nothing, and 1, 0, 0 and 1. So I want to get this. So this has to be equal to this plus another structure here. All right. So let's do it. So 3 is already there, so it has 0. 2 is already there, so it has to be 0. 3, 0. So this has to be 3. So 3 plus 0 is 3. Here 2 minus 0. So I have to have 2 here. 1, 0. So I have to have 1 here. 2, there is already 2 here. So there has to be 0. 1, there is 0 here. So I have to have 1 here. 0, 0. So 0. 1, 1, 0. So I need a structure that has this many cubes. So if we look carefully, so 0, 0, 3. So if we look at the first one, 0, 0, 3, this row is fine. And 2, 1, 0, 2, 1, 0, that is fine too. 1, 0, 0, 1, 0, 1, 0, I need a 0 here. So this is not going to work. Similarly, if you could check, actually, the one that matches is 0, 0, 3, 2, 1, 0, 1, 0, 0. D is the one that matches as the correct choice. Which of the following 4 shapes has the greatest area? So if we stare at the shapes for a moment, notice that this triangle has the same area as this triangle because they have the same base and same height. So I can disregard this and instead consider this one. Okay. Similarly, this triangle has the same area as this triangle. So I can disregard this and consider this instead. So this whole thing is filled. So if we consider this unit to be 1, this is also 1. So this area is 1. So this is 1. So I have 2 of those. So this area is 2. Okay. Similarly here, if I look at this triangle and then this triangle, they have the same area. So I can disregard this and consider this instead. Similarly, if I look at this triangle, that has the same area as this triangle. So I can disregard this and consider this instead. So this is also 2 units, right? So this also has area of 2. Let's take a look at this one next. the area of this triangle is same as area of this triangle, right? Same base, same height, right? So I can disregard this and consider this instead. Similarly, the area of this triangle is same as area of this triangle, so I can disregard this, consider this instead. So this is my final step. So this also has area of 2. Okay, so this and this, they all have area of 2. Let's take a look at the crown. Now if you carefully look, this point is not touching here, right? This point is a little bit above. If this point was here, let's say this was connected like this and it went like this, same here, it connected to the bottom and then went like this, what will be the area of this? It will be half times, the base is, if we consider this as 1 unit, this will be 2 unit, times height is also 2 unit, right? So the area is going to be 2 if this point was connected here to the base, but it is not. This point is a little bit above, so there is some extra area here, right? There is some extra area here. So this definitely has more area, more than 2. So the crown then C is the correct choice. Peter has 2 coins with a number on each side. One of the coins has the number 7 on one side and the other has the number 10 on one side. By tossing the coins and adding the numbers on top of the 2 coins, he can get 4 different results. How many different numbers can be on the opposite side of the coin with 7 on the other side? All right. So this is a coin with 7 on one side. The other side I don't know. The other coin has 10 on one side. Other side I don't know. One thing I can immediately see is 7 plus 10 is 17. There is one other number that is given to us. And we have given the other 3 sums. So 7 adds with this, and this adds with 10, and this adds with this number. We can try to guess the other 3 sums, and we can try to do it that way, but there is an easier way using algebra. So let me call it x. Let me call this y. So one sum is 7 plus 10. 7 plus 10. The other is 7 plus y. 7 plus y. Then x plus 10. X plus 10. And then x plus y. So these are the 4 different sums that are given to us. So why not I try to add all the 4 sums. So this is one of the sums, this is the other one, this is the other one, this is the other one, and these should add up to these 4 numbers. So this should be equal to 11 plus 12 plus 16 plus 17. So 7 plus 10 is 17. 17. This 10 and 7, 17 is 16. I borrow 1 from there, so remaining is 10. All right. So then I have a y, there are 2 y's and 2 x's, right? So 2x plus y, that is equal to 12 plus 10 is 22. So this tells me x plus y is half of this, so that is 11. All right, so x plus y is 11. So that is the other sum, right? All right, so I know 7 and 10, so this is 17. This is x plus y, I just figured out, that is 11. So this sum is x plus 10, and this is 7 plus y. All right, now this x plus 10 can be either of these 2 remaining sums, right? So x plus 10 can be either 12, or this x plus 10 can be 16. X plus 10 can be 16, right? So these are the 2 possible values of x. I don't have to solve it, but in this case x is going to be 2. This case x is going to be 6, right? So there are 2 possible values of x. So how many different numbers can be on the opposite side of the coin with 7? So this x can have 2 values, 2 and 6. Then B is the correct choice. In a second-hand shop, 2 hats are sold for the same price as 5 skirts. So 2 H for hat, 5 S for skirt. 3 skirts for the same price as 8 t-shirts. So 3S, 8 T for t-shirts, and 2 t-shirts for the same price as 3 caps. So 2 t-shirts, 3 C for cap. Which of the following collections is the most valuable? And we are given some collections. You can probably guess that this is a straight algebra problem. So let's try to do it that way. And we need to compare the collections. So it would be easier if we try to express everything in terms of one variable. So let's pick S. So we'll express everything in terms of S. So from here, if I divide both sides by 2, H is going to be 5 by 2 S. All right. So from here, T is going to be 3 by 8 S. All right. From here, C I can express in terms of T, and I already know T in terms of S. Okay. C is going to be 2 by 3 T, and T is 3 by 8 S. So 2 by 3 T. So and then T is equal to 3 by 8 S. So 3 cancels. This is 1/4 S. So this implies C is equal to 1 by 4 S. All right. So I have everything in terms of S. Now let me calculate the value of each of these collections. Collection A is a hat plus 5 skirts. 5 skirts. So H is equal to 5 by 2S plus 5S. So this is going to give me, denominator is 2. So this is 5S plus 10S. So this gives me 15S by 2. All right. So this is collection A. All right. So I have all the collections computed in terms of the variable S. And I can see that everything has denominator 4 except this one. So let me convert this to denominator 4 so it will be easier to compare. So this is going to be multiply 2 on both top and bottom. So this is going to be 30 S by 4. All right. Now if I compare 30, 23, 41, 37, and 15, I can see that this 41 is the biggest, right? So this is collection C. Then this is the most valuable. In Kangarooland, the alphabet used by the inhabitants has only 3 letters, K, G, and R. Below we see a crossword in Kangarooland language. When completed, it uses 4 of the 5 words. All right. Which word is not used? All right. So this is a small crossword puzzle. We can just try to solve it. Okay. Let me try. Let me mark this row. I'll try to fill in one of the words at a time for this row. So let me try with K, K, G. Erase this. So K, K is done. And this should start with the same letter K. So that will be K, G, K, K, G, K. So I'm trying this first. Okay, now I need a word that has K as the middle letter, but there is none. So this cannot be here. Okay, so this cannot be here. Now let me start with this one. K, G, K, K, G, K. Then this should be K, K, G. This is down here. K, K, G, K, K, G. But again, I end up with the same problem. I need another word which should have K as the middle letter, and there is none. So this also is not going to work. G, R, K, G, R, K. But notice that, I need another word that starts with the letter G. So this is used. There is no other word that starts with G. So this also cannot work for this. Okay. Now let's try R, GK, RGK, RGK. So I'm trying this one now. I need another word that starts with R. So that is RGG. So RGG. And then I need a word that has K as the middle letter. So that would be this one, KKG. KKG. I will use this. And then I need a letter that has G as the middle letter. So there's KGK. KGK. All right. So now I'm able to solve it, and I'm not using this word, right? So GRK. So I think this is the correct choice. But let me also try using this for this row. RGG. RGK. RGK. K should be a middle letter, so that should be this one, KKG. KKG. And then G has to be in the middle, that has to be the KGK. KGK. And in this case also, I'm not using this word, GRK, then this is the correct choice. The teacher wrote on the board the numbers 1 to 15. She then split them in 5 groups of 3. The sum of the numbers in each of the first 4 groups was, alright, this. In which group did she put the number 4? Alright, so we are given the first 4 groups. So let's try to find the total of the 5th group. The way we can do that is we can first find the total of all the 15 numbers, and the numbers from 1 all the way to 15, the sum is going to be, there is a formula for this. When we try to add the consecutive numbers, that is the last number 15 times the next number is 16 divided by 2, and this results in 120. All right, first 4 groups are 25, 27, 30 and 31, and they add up to 3, 5, 8, 113, right? So the 5th group, fifth group is then going to be 120. So this is the total sum of all the numbers, and 4 groups add up to 113. So 120 minus 113 is going to be 7. All right. So, and the 5th group is then going to be 7. Okay, and we have, each group contains three numbers, right? So let's try to, so this is the smallest sum, so it will be easier to find the 3 numbers that add up to 7. So what 3 numbers add up to 7? You know, as you can see, if I take 4, 2 and 1, this is the only way I can add 3 numbers to get 7, right? There is no other way that I can add 3 numbers and get 7. Then the question is, in which group did she put the number 4? 4 goes in the 5th group, right? 5th group is the correct choice. In the multiplication shown, A, B, C, D, E represent different digits. If the multiplication is correct, what is the letter that has the value equal to 8? All right, I need a multiplication table for 3. So let me first write that down. All right, so I have the multiplication table for 3 here. So I'm multiplying 3 with a number, and then I'm getting 1 at the unit place. So if we look at this, so here is 1 at the unit place. So 3 has to be multiplied with 7, right? So this must be 7. E must be 7. Then 3 times 7 is 21. 1 here, 2 carries over there. Okay, next, so if this E is 7, then this is also 7. This is the same letter, right? Okay, I'm multiplying 3 with some number, and then I add 2 to get a 7. So if I take away 2, the unit place should be 5. And this is the only one with unit place of 5. So 3 must be multiplied with 5. 3 times 5 is 15, plus 2 is 17. 7 goes here, 1 is carried over, right? All right. So if this d is 5, this d also has to be 5. It's the same letter, so must be same digit. Now I'm multiplying 3 with a number, and then I add 1 to get 5. So if I take away 1, the unit digit has to be 4. Now if I look here, right, 3 has to multiply with 8. So 3 times 8 is 24, plus 1 is 25. 5 stays here, 2 is carried over, right? All right. Now actually I already have my answer. We can try to complete it, but it is asking which letter has value equal to 8 and C has value equal to 8. Then C is the correct choice.